So in this video we can have to discuss about how we should have to sketch the graphs of the quadratic functions. So I beg before this lesson you should have to go through the video we discussed about the techniques on the graph sketching. We talk of the translation determinants as well as the reflection determinants, because there are the techniques you should have to use as well. And also you should have to go through a video we discussed about the basic 6 functions in their respective graphs, where you see the graph of the square function. So those things are the ones you have to use in this video, so just have to make sure that you are on those in case you missed. So what is a quadratic function? A quadratic function, this is the function with the highest degree power given as 2. And it has got the general form given as f of x is equal to x squared plus bx and plus c, where this is the constant, this is constant, and also this is the constant. And c is said to be the y-intercept, where the graph is to actually cut across the y-axis. And the nature of the value of a determines whether the graph has to concave upwards or the downwards. And as such that if the graph is concave downwards, it means the value of a is given as the negative, no matter how big or small the value is. But much as it is actually negative, it means the graph have to concave downwards. If it is positive, it means the graph have to concave upwards. So take note of that. So let me just have to highlight to you what is the typical a quadratic graph looks like. What is the typical quadratic graph looks like? Mind you, the shape of the quadratic graph possesses the shape of the parabola. Hence, the graphs of the quadratic functions are said to be the parabolic functions. So in case you are not aware about that one. So the shapes of the quadratic function, the graphs of the quadratic functions possesses the shape of the parabola. Hence, they are said to be the parabolic graphs. So this is y-axis and this is the x-axis. So should be that. Now, the typical a quadratic graph, let's say we have it as this. So this is the typical quadratic graph we should have to expect. So in this case, this is said to be the vertex or the turning point. That is vertex or the turning point. And a turning point consists with the two values. So it consists with the x value. Let me have it this way. It consists with the x, a y value, and that is. And now let's say the y value has to be symbolized as k. So that is the y value, and the x value is being symbolized as, and that should be, let's say, h. So which means at the vertex or the turning point, the coordinates are given as this. So that point consists with the two coordinates, and that should be now being given as this. We have it as h, k. So these are the coordinates at the vertex or the turning point. Now, since the graph has concave upwards, it means this is the maximum and this is the minimum point. And the value of k at this point, the value of the y coordinate at this point is said to be the minimum value. So in that case, you should also have to understand about the line of symmetry, or should be the axis of symmetry. What is the axis of symmetry for the quadratic graph? So now the axis of line of symmetry, it is the line that is to cut the graph into two parts. The which goes like this. So that is the axis of line of symmetry, and basically it is given as the x value at the turning point. That is the equation of line of symmetry, or the axis of line of symmetry. It is given as x is equal the coordinate at the turning point. It is given as x is equal to the value of the x-coordinate at the turning point, and that is basically given as, it should be h. That is the equation of line of symmetry at the turning point. You should have to understand. So take note of that. And what if the graph is to concave downwards? What would be that if the graph now, if the graph is to concave downwards? Then the principle remains the same, and that will be able to have this graph. It means if the graph is to concave downwards, it means the value of a is actually a negative. So which means we'll have that and as that. Then the graph will have to look at this. Now this will be the nature of the graph we should have to expect. And where now this one was said to be a vertex, stroma of the turning point consists with the two consists with the two coordinates, that is h, k stroma, and we'll have this as the axis of line of symmetry stroma. So take note of that. So you'll be able to understand all these things as we'll be actually sketching the graphs of the quadratic in that way. And I remember we also discussed about the parental graph of the quadratic, which we said the graph of the square function. So this we said this is the parental graph of the quadratic. Okay, this is the parental function for the quadratic function. And where we discussed that it is in this nature. So it is a piece of reminder for one another. This is the nature of that graph. So this is said to be the graph of y is equal to x squared. So this is said to be the quadratic graph or the graph of the square function. So actually the graph of the quadratic functions is based from this parental actually graph. You understand what is it about this graph, and with respect to the graph of the function, that would be in this nature. But this is the actually a parental graph. You should have to understand, much as we are dealing with the actual techniques of the actually graph sketching, which should be based much on this graph, then it will follow up based on whatever I'm going to do as far as the graph sketching is concerned. So how should we be able to come up with a sketch of, or how should we be able to actually sketch the quadratic actually a function graph using the techniques of the graph sketching? And we talk of the translation determinants and also the reflection determinants. So now, given the typical quadratic function given as x squared plus bx and plus c. Now, without the use of the table value to come up whatever the stuff we think about, now how should you be able to sketch the graph of this function? Now you should have to understand that the graph, actually the function, has to be translated in this form. Y is equal to a times x minus, that should be h squared a plus k. This is the actually translation key, or now this is said to be the actually a graphing key for this function. Should be for the quadratic functions. So this is said to be the graphing key for the quadratic function, where this is the translation determinants along y, and this is along x, and this is the constant, which is the value of a. So which is the coefficient of actually x squared. So what is h as well as k? Those are said to be the coordinates at the turning point given as h, k. So the function has to be translated in this form, and you can be able to come up with a sketch of the graph. How can you be able to have the intercepts of the actual graph? So for instance, y-intercept is obtained upon having x is equal to 0. So you have x is equal to 0 here, you solve y. You have the y-intercept. And the x-intercept, we'll have it as upon having y as 0. You solve the way we solve the quadratic equations. It will be that, but take note of that. So now, let's think of sketching the graph in this niche. Sketch the graph of the quadratic function, which is given as this. Let's say we have a function f of x is equal to, let's say, negative 2x squared, and that should be plus 4x, and that plus 6. So what is the graph of this function? Let's now first thing, what is the value of a? We have it as negative 2. And what is the value of b? We have it as a positive 4. And of course c is given as 6. It should be given as 6. And what is the general format? And what is the general graphing key for the quadratic functions or quadratic graphs? It is given as y is equal to a x minus should be h square plus k, where h as well as k, these are the coordinates at the turning point. So let's start with having h. How do you find the x coordinate at the turning point? So the formula says that we should have it as negative b over 2a. So this much we already discussed about that one. When we're discussing about the parabola, you just have to go through the lesson we discussed about the parabola. You come across that one about the x coordinate at the turning point. Only that we are symbolizing it as h instead of x. Now we'll have it as negative 4 of should be 2 times negative 2. That will be given as 1. So that's the actually a value of h. And how about the value of k? We'll have to substitute the actually h into the original function. And that will have it as that. This is the y coordinate at the turning point. So now we'll have it as negative 2, and should be that plus 4 times 1, and plus 6. Now we should have it as negative 2, and plus 4 plus 6. That will be given as 8. So that's the value of k. So now, which means we'll have it as this. So now we'll have it as this now. So this one should go as well. And by the way, we have h given as 1 and k is given as 8. So now, which means we'll have the graphing key. Now we'll have it as y is equal to, now should be negative 2, and x minus 1 square plus, now should be 8. So this is the graphing key. So what is the graph of this function? Now we should have to understand that this is the translation determinants along actually a y, which means the graph has to go 8 steps up, and this is the translation determinants along determinant along x. It means the graph has to go about 1 step to the right. Mind you, you should have to go through the techniques on the graph sketching. You come across all these conditions. And now, since the value of a is negative, it means the graph has to concave downwards. So this is the reflection. Now it means the graph has to reflect along x-axis. Now the graph has to concave downwards. That's the reflection. So what is that graph? So let me eliminate this one. And that I should have it as this point. Yes, now I'll have to sketch the graph. Mind you, we use the pencil in all cases. Now whenever now we have to sketch the graph. And the well sharpen the pencil as well. So this is y-axis, this is the x-axis. So that should not have to be forgotten. And the graph has to move 80 steps up. Let's say this is 8. Of course, I just have to make it that the axis has to be arbitrary wrong. So it should be up to this point, at least that one. So now this is y-axis, should be that. So the graph has to be about 80 steps up. Let's say this is 8. And the graph has to move about 1 step to the right. Let's say this is 1. So I'm having my 1 there. And then guess what? I'll go to the point where this one and this one are intersecting. And what's that? So which means I'll do this. I'll have the line that is going like that. And this is the point. So the two are intersecting there. So that's where the graph will be. So since the value of a is negative, it means the graph has to reflect along x-axis. And the graph will have to go like this. So which means the graph has to go like this. So the graph has to go like this. Now this is the graph of interest. So that's the graph where we have, where this is the actual turning point that consists of the coordinates given as 1, 8. Where we have the axis of line of symmetry being given as x is equal to 1. And we'll have, this is the y-intercept, where we'll have to solve y upon having x as 0. So what is the y-intercept? We'll have it as negative 2, 0, minus 1 to the power 2. So it should be plus 8. So which means I'll have it as a negative 1 to the power 2 is given as 2, should be a positive 1, negative 2 plus 8. So which means I'll have it as 6. So which means here we have it as 6. That is the y-intercept. And how about the x-intercept? I'll have it as, now I'll have to solve for x upon having actually y as 0. So now I'll have it as this for the x-intercept. I need to have in this way, 0 is equal to negative 2 x minus 1 to the power 2 plus 8. So which means I'll have it as now x minus 1 to the power 2 plus 8 is equal, should be, so I've divided everything. Now should be that, actually should be like this. So the 8 has to be transferred to this side. So that is the same as negative 8 is equal to negative 2 x minus 4 to the power 2. And of which we'll have to divide everything by, and that should be negative 4. That will be given as, now I'll have it as a 4 is equal, by the way you should have to divide everything by negative 2. Now I'll have it as a 4 is equal to x minus 4, and that should be that. So that's the principle behind everything there. But now I'm having this. By the way, to the power 2 here. So since I'm looking for actually x inside, we'll have to introduce square both sides. That will have it as, should be this. And also this side will have it as a plus or minus. By the way, don't forget that one. So now which means I'll have it as x minus 4 is equal to, now should be plus or minus, now should be 2. So which means I'll have x being given as 4 plus or minus 2. That will be given as x is equal to, now we'll have it as, should be 4 plus 2, that will be given as 6. And we'll have x is equal to 4 minus 2, that will be given as, now should be given as 2. So these are the actually the x-intercepts now for the actually graph. Although it seems that the graph is somewhere about actually the values about this actually side where the x values has to be negative. Actually the x values has to be negative. Actually the x values has to be negatives, but that is the way to go. Only that the problem was the way I was sketching that on. But take note of that. What if we should have to sketch this graph? Of course, we had problems in solving this one. What's going on here? We happen to have, I don't know where did I got this for. What happened there? So should be 1 here. So have this one as 4, should be given, have this one as 1. Now it will be in a light way. So this is 1. And I will have here as 4, should be as 1. That will be this one as 3. So that one. Some of the 3 mistakes that the students tend to do as well. So be careful. In case you're in exams, you should be very careful. So it should be 3 there. So now which means I'll have 1 there. I'll have 1 in such that I'll have a negative 1, which is now pretty fine. It means what we did was all perfect. This is negative 1. So it should be this is negative 1. So it means this is now it means this is a negative 1 and this is positive 3. So those are the actual x-intercepts and are for the function. So take note of that. Now how about if we have this case now? We should have to understand about, let's say we have a function. Let's say we have this function. Let's say the function is given as y is equal to, now should be x squared minus 2x, and that should be plus 3. So what is that one? Now we have a being given as, and that should be 1, and then we have b being given as negative 2, and of course c is given as 3. Now we should have to graph or sketch this actually the graph of this quadratic function. Now principle remains the same. What is the graphing key? We have it as y is equal to ax minus h square plus k. So now what is actually h is given as negative b over 2a. That is the same as, now we'll have it as negative, and this negative will have it as a positive. So that will be given as positive 2 divided by, now should be 2. that will be that will be given as 1. So take note of that. And then the next we should have to solve for k. What is k? We'll have to substitute h into the original function. And mind you, k is the y value, so have it as 1 to the power 2 minus 2 1 and the plus 3, and that will be given as 1 minus 2 plus 3. Now we'll have it as we'll have it as a 2. That is the k value. So it means the point of interest, that is the turning point, consists of the coordinates given as 1, 2. So now have it as y is equal to, now a is given as 1, we'll have it as x minus 1 square plus, now should be 2. Now this is the translation, or should be a graphing key we should have to use. So what would be that graph? On the same principle, so have it as this. Now I have to go over like this stuff. So now this is the y-axis and this is the x-axis. Now the graph has to go about 2 steps up. So let's say this is 2. And that has to go 1 step to the right. Since it is a positive, actually since it is negative, it means it will go like this. Let's say this is 1. So where are the two intersecting? So it means this is the point of interest. Let me just have to do it this way. It should be the same way, by the way, or have it in this case. So it should be this. So which means this is where the graph has to be. And it has to go like this. So that's the graph you should have to understand. So where at this point consists the coordinates given as 1, 2. And the axis of line of symmetry is given as x is equal to 1. And it is this line, basically. And how about that of, let's say, the graph has no x-intercepts, because the graph is up here and the x-axis it is down here, so it has no x-intercepts. How about the y-intercept? Also do the same, where the x will be given as, also have it as y is equal to, now 0 minus 1 to the power 2 plus 2, that will be given as 1 plus 2, have it as 3. So which means this is 3. So that is the y-intercept, and therefore that case. Also, let's think of having this problem. Let's say we have a function f of x, and is given as, let's say, negative x squared, let's say plus 6x plus 2. Let's say this is the typical function. So in this case we have a being given as negative 1, and we have b being given as 6, and c is given as the positive 2. So what is the actually a graphing key? We have it as a x minus h to the power 2 and plus k, where h is given as negative b over 2a. Now have negative 6 divided by 2 times negative 1, that is the same as, we should have it as a positive 3. Now how about a k, which is the x value, actually should be a y value. Now we'll have it as a k is equal to, now negative 3 to the power 2. 6, 2 should be 6, 3. So it should be 6 times 3 in the plus 2. That will be given as negative 9 plus now should be 18 in the plus 2. That will be given as now should be given as 11. So that is the actually gay value. So which means we'll have it in this case. Now which means we'll have it in this case. So let me just have to create some space here. Therefore now which means I'll have it as f of x is equal to negative the x the minus 3 square the plus, and that should be now plus 11. So that's the actual graphing key. So now what is that graph? So now I have to do like this, the same way we are doing. So this is y and this is x. So the graph has to go about 11 steps up. So which means let's say this is 11, and that should be about 2 steps to the right, 3 steps to the right. Let's say this is 3. So it will be like that. So which means we'll have it in this case. So the graph has to be here, and since a is negative, it means the graph has to reflect about x-axis down. So the graph has to concave downwards. So which means it will go like this. So that is the graph. So try to have the intercepts in that way, and also what is the line of symmetry. And also, since the graph is concave downwards, you should have to identify what is the maximum value. You should have to identify whether it will have the maximum value or minimum value according to the way I've expressed that one before. So try that one. Now what if we are given this case? Let's say have y is equal to, let's say negative 2 x plus 4 square, let's say minus 5. Now what is the graph of this function? Now it is already in the form that you can be able to have the sketch of the graph. So which means the graph has to reflect about x-axis and has to concave downwards, and the graph has to move about 4 steps to the left, and the graph has to move about 5 steps down. So what would be that one? So now we'll have it in this case. It means the graph will be like this, and that should be about, this is y and this is x. So the graph has to move about 5 steps down. I'll have this as the 5. Let's say this is negative 5. And since it's positive here, it means the graph has to move about actually 4 steps to the left. So have it as, let's say this is negative 4. So it means we'll have it as this. So that will be now being given as, now the graph will be concave downwards or reflect along x-axis. Now the graph will have to go like this. So the graph has to go like this. So should be that. So take note of that. So at the end time, try to have the graphs of the following functions. Now we have, let's say y is equal to, and that should be x squared minus 2x and that minus 3. We have y is equal to, now should be 2x squared and that plus the square root of 2x, and I'll have y is equal to, let's say 2x plus, let's say 5 square minus 4. Let's say y is equal to, let's say negative 2x minus 12 and the minus, let's say 20. Also try that one as well at your own time. What if we have, let's say AC is equal to negative a quarter and that should be a t squared and that plus t minus 1. Also try to have that one as well. So that is, and also you have to understand that sometimes, let's say for instance, we know that for us to have the graph of this one, we should have to translate it in this form: y is equal to a x minus h squared plus k. Now sometimes without going over our steps to have h as well as k, sometimes the simplest way is also to just have to we use the computed square method to express this one and to be in this form. So can we try to look over that one, how can we be able to express this one and that to be in this form without going over those steps to have h as well as k. So try to actually search even from different books or Google to look at how can be able to use the computed square method to have this actual function to be in this form, where you can be able to have the sketch of this graph in this nature. So try to look for that one. But it is good to know that method as well, because it seems to be a much easier to work out with, only if you may have an interest to, but try to look over that one. So thank you.